Yeah, today our topic is carbon compounds. And its compound. First of all, we have to see the first word, that is the element, that is the carbon. So, what is the carbon? Carbon actually atomic number is 6 and its and 12 is it atomic mass. Hydrogen, helium, lithium, beryllium, boron, and carbon. 1, 2, 3, 4, 5, and 6. So, what that does means that here the nucleus, here a electron, here two electron in the first shell, and then the next shell it got four electrons. So basically, if we have to group its electron in terms of shell, then this is KLM. So when we, what is the formula to find out the number of electron in a particular shell? This is n square. So first n1, so n1 square, 1 gives 2. So if for the uh, second cell, if we want to see that it's 8, so first 2, then second 4. So as we know that all electron, according to the octet rule, all element have to complete octet or have 8 electron in outermost shell to get stable noble gas configuration. Now to do so, what carbon can do? Carbon can gain 4 electron or lose 4 electron, because if it lose 4 electron, right, it will be 2 electron only left. So 2 electron is obviously the stable state of the helium gas. So helium is also a noble gas. So on that basis, the carbon can lose 4 electron or lose 4 electrons or gain 4 electrons. Carbon can't do both. Q, why both? What? Why carbon can't do both? Because if lose 4 electron, then nucleus will attract rest to electron. If we gain 4 electron, then it make nucleus unstable to hold 8 electron, as early that was holding 4 electron. As early we know that only the carbon was if we gain 4 electron, then early the atom was holding only 4 electron. Now they got extra 4 electrons, so that obviously we make the atom unstable, because nucleus can't hold more 4 electron. That can be too much for the nucleus. At the same time, if it loses 4 electron, then the nucleus will attract rest to 2 electrons towards it, because the force of attraction will gradually increase more. Carbon solve this by sharing of electron. Carbon can solve this problem by sharing of the electron. So carbon form covalent bond. That bond is formed by the sharing of the electron. to get stable noble gas configuration. So now we see how the atoms share electron to form a stable kind of configuration. For like a hydrogen atom, only one electron exists. So for another hydrogen atom, only one electron exists. So to gain its stable noble gas configuration of the helium, then it should have two electrons. So the hydrogen atom, what will do? Probably here it shares. Actually, we can form it like cross represent the electron of hydrogen 1 and for hydrogen 2 dot. So the common bond formed with the covalent bond. So this bond that is formed between the two hydrogen atoms is known as the covalent bond. Same we can make from the nitrogen atom. Nitrogen, as we know, is hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen. It's the seventh one. Seventh one for its two is outer and the rest five. So if we have five electrons, 1, 2, 3, 4, and 5. So three electrons is x, five electrons are there. So 1, 2, 3. So this formed a triple covalent bond, so N2 will be formed. Therefore, there is issue between for the camera. Now, as we see the N2 and H2, now we're gonna see it for carbon atom. So carbon, like the classical example that we can take is for CH4, that is the methane. Methane, as we know that the carbon have four electron at outermost shell, 1, 2, 3, and 4. And for hydrogen, we're gonna represent it with the cross. So here the X circle represents the orbit, and here another circle. So if we take the outermost, so this is the common structure of the methane. Actually, if we're gonna say that there are basically the big circle is the orbit of carbon, where you can say the 1, 2, 3, 4 are the four dots are the four electrons of the carbon, and the four cross 1, 2, 3, 4 are the four hydrogen atom cross. So hydrogen oxygen compare the outer orbits by forming a cross and dot bond. That is the again the covalent bond that is formed between hydrogen and the one electron of the carbon atom. So also is contained the hydrogen orbital of H2 make it a make it a helium. So we have seen this in basically in this chapter, that is the carbon and its compound. So carbon is a 6, that is atomic number, its atomic mass is 12. So it have 2 electrons in its first shell and 4 electrons in the other outer shell. So according to the orbital rule, it need 4 electrons in the outer shell to get stable noble configuration. To do so, carbon can give 4 electron, lose 4 electron. Carbon can do both. So if lose 4 electron, then it will attract rest 2, and if gain 4 electron, it make nucleus unstable to hold 8 electron, as earlier it was holding 4 electrons. Carbon can solve this problem by sharing of the electron. Carbon forms a covalent bond to get stable noble gas configuration. So as we see in the case of methane, the dots that represent 1, 2, 3, 4 are the carbon at carbon electrons, and the cross that represents hydrogen electrons. So when we use dot and cross, it stabilize the hydrogen valency, and if we take dot and cross for the carbon, that is stabilize the carbon valency. This way we can say the single carbon atom can be satisfied by 4 hydrogen atom, and we also same for the nitrogen aspect and for the helium also, helium for H2 also. Basically this is the basic introduction of the chapter, why the covalent bonds are formed, why there is sharing of electrons, and why carbon use the sharing method, not the other method of it, and how other sharing of the, and basically this structure that we form basically is the Lewis dot structure, because our electron dot structure, as there are electron and basically represented dot form, so it's electron structure, or we can say also Lewis dot structure.